I'll go.
Hello, 356 members. This is the first in a series of technical presentations put on by the 356 Registry Technical Committee. And since I'm the first guinea pig, I got to choose the topic. So I selected something I know a little bit about, which is the 356 electrical system. The objective of the presentation is to first familiarize you with the fuse box, including some simple maintenance items, and second, to discuss the power source and how it is distributed to the 20+ circuits in the 356 electrical system. It's aimed at the 356 enthusiast and not necessarily at a technician or a mechanic, but the presentation is quite technical, and my hope is to increase your knowledge of your 356's electrical system. Please ask questions as we go by typing them into the chat box. Well, where to start? This is the entire electrical system for the 356. In this case, it's for a 60 or a 61 T5. And this presentation is based on these models, but it's very similar to the systems that came before and after. Depending on how you count them or group them, there are 20 to 30 circuits in the 356 electrical system. I selected the fuse box as the first item to cover. It's one of the most visible items of the electrical system and probably the most accessible. It's one of the most visible items of the electrical system and probably the most accessible to the owner. And it's usually the first place to go when something electrical is not working. Once we examine the fuse box, we will look at the power source and distribution diagram. That is, how power is delivered to each circuit in the car. This is a must-know for troubleshooting any electrical problem. Here's a very nice looking fuse box. It's clean and orderly. Wires look new. Maybe it's a replacement harness, possibly a restored car by the look of the tidy luggage compartment. Here's maybe a more average fuse box, or hopefully below average fuse box. Take a quick look at how many problems can you find besides the paint over spray on the relays. While you're looking, I'll just say that it was probably working okay. It's not pretty, certainly. And basically, this same fuse box was used from the 54 model year through the end of 356 production. Okay, I'll tell you what I found. First, there's no cover. The cover protects the delicate parts of the fuse box from items in the trunk so that the fuses don't get dislodged. Also, the legend is attached, which identifies the circuits associated with each fuse, which really helps when you're looking at the fuse box. Secondly, we've got some wrong fuses in here. The red fuses are 16 amp fuses and are not spec'd for a 356. The glass fuses are American-made bus fuses. They may be correct amperage and entirely okay. They don't look authentic, though, and there goes your first place at Amelia Island. I included the notes from the owner's manual that states that there are 2 fuses specified for the 6-volt 356, a 25/40 fuse, which is the blue fuses, and an 8/15 fuse, or the white fuses. The 25/40 designation, what does that mean? That means that this fuse will pass 25 amps continuously. It'll tolerate occasional spikes up to 39 amps, and it blows at 40 amps or more. Okay, next, there are extra wires for some long gone accessory, and they're nicely set off by those household wire nuts, don't you think? There are also some unknown receptacles or quick release connectors, half of it at any rate. If this was my car, I'd clean this up. Wires dangling from the wire harness are never a good thing. I had to look at it for a while, but I discovered that the horn relay is not wired correctly. The relay on the right is correct, and you see the location of the main power wire by that yellow arrow. On the left, notice that the large red wire from fuse number 3 is going to the back right corner of the relay. As with most relays, they're split into a low current control side and a high current working side. So by swapping the wires, the result is that the large current required for operating the horns is passing through a wire about 1/3 the size of the intended wire. And you'll see this small wire here with the yellow line on it. All of the current to blow the horns is going through that small wire. Did it work? Yeah, probably, but it's not right. Okay, let's go back to a nicer example of a fuse box. One of our members sent this to me. It's very original and unmolested fuse box. The wire routing is very neat. Everything looks very clean and orderly. Okay, let's shift gears and look at the diagram of the fuse box. This diagram is turned 90 degrees clockwise from the previous pictures. And it's got wires coming in and wires going out. The wires on the left are all going out to individual circuits. On the right, it's a little more complex as you have some wires coming in and others going out. But we'll look at this in detail shortly. Notice the heavy black ties between the fuses. That's these ties here. You can't see them on your fuse box, but they're there. Those black lines represent the brass connectors or bus bars that are on the back side of the fuse box. These perform several important functions, and I'll point those out as we go through the fuses one by one. Notice the grouping of the fuses. You've got 1 by itself, you got 3, and you've got 2, 2, 2, and 2. This basic arrangement was used from late 54 through the end of 356 production. Okay, let's go through the fuses one by one. Here's a close-up of fuse number 1. Fuse number 1 is unique. It's the only fuse that turns on and off with the key position. Power comes into the fuse on the single black wire on the right side from ignition switch number 15. The outputs on the left are the turn signal flashers, the backup lights, and the brake lights. Fuses 2, 3, and 4 are always hot. That is, there's battery voltage present at them at all times. This is kind of the heart of the fuse box. Note the large 10mm square wire attached to the right side of fuse number 2 coming directly from the battery. It supplies power to the entire car with the exception of the starter motor. Next, note the vertical black line. That's that brass strip that we saw on the back side of the fuse box, and it distributes battery voltage to fuses 2, 3, and 4. 6 circuits are powered from this bus bar, both fused and unfused. you see that power is distributed from this bus to the horn relay at fuse number 3 and to the light switch at fuse number 4. These are totally unfused. On the left side of the fuse box, or the bottom in the photo, fuse circuits go to the cigar lighter and the clock and the windshield wipers and the dome lights. So here's a question for you. Does the wire that says to the light switch, does it have anything to do really with fuse number 4 and the wires to the left on the output side of the fuse box? Well, that answer is no. That wire is connected to fuse number 4 as a convenient place to attach the wire to distribute the power throughout the car. Okay, so we've gone through fuses 1, 2, 3, and 4. Let's move on to the fuses in the middle of the fuse box. There's fuses 5 and 6. They're the fog lights. The yellow and white striped wire on the right comes from the fog light switch, and power is distributed to both fuses through the connecting bus. Another use for that bus bar. Fuses 7 and 8 are all the running lights, the front parking lights, tail lights, and license plate lights. Notice that power to the right side of fuse number 7 comes in on the gray wire from the light switch terminal number 58. So when you pull your light switch out, it energizes both fuses number 7 and 8. But interestingly, the fog light circuit picks up its power as well from this power source. This allows the fog light to operate only when the light switch is on, and it gives the added benefit of automatically turning off the fog lights when the light switch is turned off. Okay, fuses 9 and 10 are the low beams, and 11 and 12 are the high beams. You can see that there are 2 yellow wires on the right side, or the input side, of the low beams. The wire on fuse 9 is the primary source of power for the low beams, and it comes from the combination switch on the turn signal stock on a T5 or T6, and from the dip switch on an older car. The wire on the right side of fuse 10 comes from the light control relay. This is part of the headlight flash feature. This is another use of the bus bar connection, allowing 2 independent inputs to operate the circuit. The high beams only have 1 wire connected on the input side. The high beam power supply always goes through the signal light control relay. The headlight circuit will be covered in a future presentation. Direct your attention to the left side of fuses number 11 and 12. In addition to the white wires going to the right and left headlights, there's a gray wire on fuse 11 going to the fog light relay, which disables fog lights when the high beams are on. And the blue-white stripe wire on fuse number 12 goes to the high beam indicator light on the tachometer to tell the driver that the high beams are on or off. Okay, so that's all the fuses. Went through it quickly, but it gives you an overview of where all those circuits go. Here's an interesting view of a C fuse box that you don't see every day. And there's the back side of that fuse box. And you can see those bus bars that we were talking about here. You can see those bus bars. Here's another style of fuse box. This is from a 53 model car. Beautiful preserved car. Notice the fabric covered wire. This was a feature on the older cars. You'll also notice on this fuse box that fuse number 2 was shorter and has a spacer. And I believe this was for a slow blow fuse. But it appears that maybe these slow blow fuses that were popular in the 50s are no longer available, or there'd probably be one in this really nicely preserved car. Here's the back side of the older fuse box. Note the bus bar configuration from this car. This is a late 53 fuse box. And you can see how the input side of the fuse box was ganged differently than the fuse box we were looking at earlier. Instead of the 1, 3, 2, 2, 2, 2, we've got 1, 3, 3, 1, 2, and 2. And these cars evolved over the years, and this is just an earlier version of the fuse box. Here's a brand new replacement fuse box. This comes from a vendor named Refuse that advertises in the Registry magazine. You might see it. And if you're more concerned about functionality over authenticity, then this will fill the bill with modern fuses and very nice looking unit. Okay, let's take a few minutes to talk about fuse box maintenance. Before you start any fuse box work, disconnect the ground strap from the battery. You don't want to short anything out or start any fires. One of the simplest and easiest things to do is spin the fuses occasionally. If you're in your trunk area, take that cover off, just spin the fuses around. It may improve the contact between the fuse and the fuse holder. Occasionally, you may find that the fuse fits very loosely between the post and the little spring blade that holds the fuse in. You can gently bend that spring tab toward the middle to tighten the fuse up. But let me emphasize gently. Remember that the newest 356 fuse box is 57 years old. Joe Leone advocated putting a piece of small vinyl tubing between these tabs and the lugs to push out on these tabs and keep the fuses tight. If you've never tightened the screws on your fuse box, you may be surprised at just how loose they feel when you do. Notice that I'm holding the lug with a wrench. It just happens to be 1/4 inch exactly while I'm tightening this screw. And this will keep you from breaking the plastic when you tighten the screw. And this definitely fits into one of those "don't ask me how I know this" category. One thing to beware of is that the screws have yellow paint on them from a Porsche factory inspector way back in the day, and tightening the screw will chip and dislodge the paint. So if that's important to you, either don't tighten the screws, or if you do, you can touch it up with some appropriately colored paint. If your fuses are old, mismatched, been sitting for 10 years, just replace them. They're not very expensive, and it'll help that junction between the fuse and the holders. Well, you can solder the bus bars on the back of the fuse. Now, this obviously goes beyond regular maintenance, but if the opportunity arises, solder the bus bars to the rivets that hold them in place. This can really improve the circuit. You would probably do this during restoration or other major work on the electrical system, such as replacing a harness. These brass strips and the rivets can be cleaned with a product called deoxit or some similar product that would be available from an electronic supplier, and use a small wire brush and just clean any oxidation off. Then using a high-powered soldering iron to quickly heat the area. What you see here is a large 325-watt Weller iron to quickly heat the area to be soldered, flow the solder, and then immediately cool it after the solder flows. I have a pan of water here that I would dip the fuse box into after I soldered them. Also, there's a lower melting temp solder available. However, I used regular 60-40 solder on this particular job, and it seemed to work pretty well. Okay, well, we talked about the fuse box, and there's a lot going on there. But if you don't have a pretty deep understanding of the 356 electrical system, it's difficult to know whether a wire is coming in or going out, should it have power going to it, and so on. So where do you start when you're troubleshooting a problem? Well, there is a key piece of information that you need to do effective troubleshooting and to fully understand the 356 electrical system. And that key piece of information is, where does each circuit derive its power? Well, here's a power source and distribution diagram for the 356 electrical system. Every circuit in the car is represented in this chart. Doesn't look like it, but it is. And depending on how you want to count or group them, there are over 20 circuits. And if you are very liberal, you can count up to 30 circuits if you count, say, right and left headlights as two separate circuits, for example. We'll look at this from top to bottom, and we're going to start with the two wires attached to the battery positive post. One is a large black 35 millimeter square wire, actually cable, that goes to the starter. And then there's a 10 millimeter red wire that's attached at fuse number 2. It goes from the battery positive post to fuse number 2. The black cable goes to the starter motor, and it carries several hundred amps during cranking. It also carries current back to the battery from the B+ terminal of the voltage regulator when the motor is running. Now let's look at the big red wire from the battery to number 2 fuse on the fuse box. That's the second biggest wire in the car, next to the battery cable. So with this red wire, and that's this red wire I'm looking at right here. This wire carries all the current to power the 20+ circuits in the 356 electrical system. Note the heavy black lines at fuse number 2, 3, and 4. Again, that represents that brass bus bar that we saw a minute ago, connecting the three fuse lugs on the back side of the fuse box. So we're using our X-ray vision to see them here. Battery voltage is supplied to each of these three fuses. It also provides a handy connection to supply battery voltage to the horn relay that you see coming off at the top of fuse number 3, and to the light switch, which comes off the top of fuse number 4. These two circuits are unfused, as you can see. Power is also supplied to 4 fused circuits, the cigar lighter and the clock on fuse number 4, and on fuse number 2, the interior lights and the windshield wipers. Fuse number 3 is basically a spare for adding an additional accessory, such as a gas heater or an electric sunroof, for example. Here's a quick note about metric wire sizes. The cable we just talked about is a 10 millimeters squared wire. That's 10 square millimeters in cross section. That is, if you looked at the end of the wire, the copper conductor you see has an area of 10 square millimeters. The large wire that supplies the starter has a cross section of 35 square millimeters. Some other cables, the wire to the light switch is a big wire. It's 6 millimeters squared. The horn relay is 2.5 millimeters squared. A lot of 2.5 millimeters square wires in the 356 electrical system. The wipers are 1.5 millimeters square. Courtesy lights are 1 millimeter square. And all the way down to the instrument lights, which are 0.75 millimeters square, very small wire. So the size of the wire is determined by the electrical system designer based on the amount of maximum current or amperage that the wire is expected to cover. So that's what those little numbers are on the that you're seeing on those wires. Okay, let's move on to the light switch. The 6 millimeter square wire from the top of fuse number 4 to the number 30 terminal on the light switch. The number 30 is a designation is a DIN standard that indicates a connection that always has battery voltage, or it's hot all the time, as we say. There are 2 other wires ganged together at the 30 terminal. One is powered to the headlight flasher down here, this wire here. And the other is power to the ignition switch. So why, you might ask, does the power to the ignition switch go through, in quotes, the light switch? Well, like the bus above that we looked at on fuses 2, 3, and 4, this is a convenient junction to distribute power, and that's why it's connected there. We also see circuits related to other circuits related to the light switch. At 6 o'clock, you see number 56. And that's power to the high-low beam switch in the turn signal combo switch, or the foot-operated dip switch in older cars. At 4 o'clock, wire number 58 goes to fuse 7 and 8 for the tail lights and the front parking lights. Also the license plate lights, like we saw in that earlier fuse box diagram. At 3 o'clock is number 57. This is a T5 and a T6 feature. It energizes the light control relay and the parking light indicator when the light switch is pulled to the first detent. And finally, up there at 10 o'clock is number 58B, which powers the instrument lights. Okay, let's go back to the ignition switch and look at that red 4mm square wire coming off of terminals number 30. That wire goes to the ignition switch, and it goes to the terminal number 30 in the ignition switch. Main power for the ignition switch. The ignition switch has a lot going on. As you can see, the switch has 4 positions represented by this paddle and by the dotted lines. First is the off position, and it's shown in the off position right now, as are all components in most electrical wiring diagrams, including switches, relays, and solenoids. Is kind of a standard that they're shown in their off position. Next, and to the right is the accessory position, where the radio can be played without energizing any of the other circuits, controlled by the ignition switch. And to the left, the on position, right here. This powers the 15 circuits. The fourth position is on the far left, and that's the start position, where the starter solenoid is energized to activate the starter. That's over here, number 50, and it goes directly to the starter solenoid. And then when the key is released, it springs back to that central position, and the number 50 terminal is no longer in play, and the number 15 and the number 54 circuits are active with the ignition on. The number 15 circuits are very important for the running of the electrical system. This is another DIN standard. All number 15 circuits are switched. That is, they go on and off with the key. There is the power to the ignition coil, number 15 terminal. You see that right here. Power to the instruments and indicator lights, that's up here. And it provides power to the number 1 fuse. Number 1 fuse powers and protects the backup light circuit, the brake light switch, and the turn signal flasher. Note on this diagram that the electric tack is spliced to the wire going to the number 1 fuse. That's right here. This is a feature on C cars from about April of 1964, when the electric tack was introduced. Well, that's the power distribution in a nutshell. There's a lot of information there, but understanding where each circuit derives its power is invaluable, more than invaluable, necessary to understanding the circuit and troubleshooting problems when they arise. Thank you very much for joining me, and keep all the smoke inside your wires. Very good. Thank you.